All right. Good afternoon and welcome to everybody who is getting joined in. We went ahead and started here just a few seconds early to give everybody who was, waiting to join the call an opportunity to actually get into the call. There's oftentimes a few seconds or, upwards of really 20-second delay before Zoom will put you in even after we hit start. So want to make sure that you're in before we start talking about the important stuff. And fortunately, we don't start talking about the important stuff until we know you're here. So that's why we fill this time with a little bit of space and just talking. And at this point, we know we can start. So welcome and thank you all for being here. We know it's a lot to get away from your customers, whether you're out in the field talking to technicians, face to face, or you're dealing with those DIY customers at the counter. We appreciate you taking some time away to listen to what we have to say. And hopefully, you're going to take something away from this that's going to assist you and help you with those conversations you're having with those customers very soon, very quickly, hopefully even today. And obviously, today's conversation, the topic we're going to be covering is evaporative emissions systems. And I think this is going to be an eye opener for you when it comes to some of the, the category that we have, what it looks like as far as breadth of coverage goes, and really what it looks like for the technicians, how often they're working on this nowadays. It's one of those categories that's going to be right up there with some of the higher end categories like ignition coils and cam and crank sensors and things like that. And if we're not talking about it yet, we're going to be very soon. And again, hopefully right after this call. So again, today's topic is evaporative emission systems, but please don't forget, take down that website there, the napateamtraining.com. That way you can go and register for the rest of the calls for the rest of this year. Next month, we're going to be talking about advanced ice technologies. Then, of course, ignition coils, VVT, and so on and so forth. We don't want you to miss an opportunity to visit with those webinars as well. If you don't have time to go there, I know you probably don't right now, just pull your phone out, take a picture of that training link, and that'll give you an opportunity to go just throw that in the URL anytime you have an opportunity and get registered for those upcoming calls that we're going to have throughout the rest of the year. So again, today's topic of conversation is evaporative emissions control. And here's why we're talking about it. In 2024, the fifth most common check engine related repair was replace evaporative emissions purge control valve. That's a pretty bold statement as far as I'm concerned. I mean, when we go into a shop and there's a diagnosis being done on a check engine, it's usually related to a million other things outside of evap. It could be related to the oxygen sensors, the fuel injectors, ignition coils, so many different categories. But the reality is cars are all running with some form of evap emission system today. And because of that, and because we have purge in all of these systems, if the purge is not working properly, that check engine light is going to come on, and we see it's a pretty common issue now. Again, the fifth most common in 2024. So your technicians are seeing this, they're diagnosing this, and they're fixing this, and they need to know that you have everything available for them when those cars come through their bays. Now, here's the thing. When it comes to evaporative emissions, that check engine light is generally speaking the first point of contact that most people are going to be familiar with. And what I mean by that is, motorists are not going into the shop and saying, "Hey, technician, my car smells," or it's making a funny noise, or it's making a funny sound, or it just doesn't run right. Typically, the concern is just that the check engine light is on. They're not experiencing anything. They just know that the concern is the light has come on. Now, in the older days, there may have been some drivability concerns, but for the most part, it is now a no symptom emissions related failure that's going to turn that check engine light on and bring that customer into the shop. And oftentimes, depending on where you are, I know I've lived in multiple areas where this is true. If it's that time of year where you have to renew your tag and you have to go get an emissions test done, well, guess what? If that check engine light's on, you're not going to pass that emissions test. And so a lot of times these vehicles go into the shop, they've been driving around for thousands of miles with that check engine light on because the customer didn't feel anything. They didn't have a symptom, so they didn't care. The light's on, but the car's running. Well, now they got to get that tag renewed. So they're going to go into the shop and say, "Hey, can you turn this off?" And they're going to say, "Hey, no, we can't. We actually have to fix something." So our goal here is just to kind of high level view, understand the emission system, or more, specifically the evaporative emission system. Why do we have them? What's the benefit of them, and how do they operate? And so keep in mind when it comes to, why do we have them? The reason why is that the EPA and the CARB, they have put mandates on manufacturers on evaporative emissions. Now, they don't tell the manufacturers exactly what they have to do. They don't say, hey, you need to put this on the car, you need to put one of those or these on the car. They really leave it up to the manufacturer and they say, hey, you know what? At the end of the day, we don't care how you achieve this goal, but the goal is that this system, any system on any car, has to prevent hydrocarbons from leaking into the atmosphere. Don't care how you do it, don't care what you use, as long as you're not leaking hydrocarbons into the atmosphere. So, different manufacturers use different strategies, different components, but it's all to achieve that end goal of keeping hydrocarbons from, leaking and being released into the atmosphere. That's all the EPA and CARB asked. Just make sure that doesn't happen. How you do it, not our problem. Hopefully there will be a consensus on what that looks like one day. But for now, for technicians, there's a lot of diagnoses that they have to go through on different manufacturers just to get this job done and make sure that it's not doing exactly that, releasing those hydrocarbons into the atmosphere. So we're going to talk really quickly about how it works, what types of leak detection systems, because really at the end of the day, we have to make sure it's not leaking. That's where we're going to get those, atmospheric bleeds. So we got to make sure it's not going to leak. So what are those like? What do those look like? What are those types of leak detection systems? We'll talk a little bit about how most of these will fail, the primary reasons why they fail, a couple of quick tech tips to maybe avoid a comeback in the future. And then I'm going to pass it over to Jesse to talk about some engineering improvements that we've done to make our parts more durable when it comes to EVAP emissions. He's also going to talk about the competitive landscape, which I think you'll be happy about because you're going to see, just like most categories in the Echlin brand, there's nobody out there that's going to be able to surpass our excellence when it comes to the competitive landscape. And then we'll wrap up with Aaron talking about some of the sales support material we've put together for you so that you can go out and have these good conversations and be able to back up what you're talking about. So how does it work? Well, it's kind of simple. You got to think about it from the perspective of, let's say we're at the tank, we're at the gas station, we're putting fuel in the tank. Well, there's going to be air that's going to be displaced in the tank. It's got to go somewhere. And when you're putting fuel in, there's going to be vapors and they have to go somewhere as well. And so this is where EPA and CARB, the lawmakers, told the manufacturers, those are the vapors that you have to catch. You have to contain those vapors. We don't care how or what method you use, but we are going to put a couple of rules in place that are going to make sure that you do get this done and that the PCM is going to test for. And so what the PCM is going to test for, and this is what will be the difference between the check engine light being on or off, it has to verify that there is purge flow so that it can draw the fumes out of the storage area. You see on the schematic here, we have a purge valve. That has to work properly. You have to verify that there are no leaks into the atmosphere. Well, with the purge valve, the vent valve, the fuel tank pressure sensor, that's all going to be loaded and sending information to the PCM. And if it sees a deviation, that's going to put the check engine light on as well. And then we have to monitor all those components. That's what I just said, and make sure that the circuit is working. There are no out of range values. If there are out of range values, that's where that dash light's going to pop up and indicate that we have an issue, even if the vehicle is driving just fine. Again, remember, a lot of times these are no symptom check engine lights. It's just the PCM knows something is not working correctly. So, we look at the schematic here, you can see we have the fuel tank being filled. The fuel tank pressure sensor is reading that pressure. It's also allowing those vapors to be sent over to the vapor canister or the charcoal canister. And in order to get those vapors in there, we need to add a little bit of air and a little bit of pressure or vacuum to pull those vapors into the canister. And that's where our vent valve comes in. Our vent valve is going to open. It's going to allow air to go in, draw in with that vapor. It's all going to mix. And then when the timing is right and the conditions are just right, and typically speaking, when the canister is ready to get rid of what all is being, filled up in there, the purge valve is going to open. It's going to take those vapors and that air, and it's going to send them into the intake manifold to be reburned. So it's a sealed system. What we're doing is we're trapping that air and we're trapping those vapors in the canister. And when that canister is full, or at another point in time when you're driving and the PCM feels the need, it's going to purge that canister of that vapor and that air and reburn it into the intake manifold. And then we're not going to have a car that smells like dirty fuel. It's not going to be like the 70s, 80s, and 90s whenever you would be behind a car that may have not had a lot of maintenance done over the course of a few years sitting at a red light and all you can smell is fuel coming out of it. Well, this is what's going to prevent that on all these newer vehicles. That keeps that trapped and contained within the system. And so this is the primary typical EVAP system layout. And it can look different on different vehicles. Some vehicles will not have a fuel tank pressure sensor. Some will have a vent and purge valve combination. It just depends on the vehicle and the manufacturer, because again, there was no specific way it had to be done, just that it did have to be done. So manufacturers have done things a little differently. And so here's a couple of the systems, or really the primary systems that you're going to find in vehicles that are the types of leak detection systems. These are the systems that let the PCM know if there's a leak or if there is not a leak and keeps that check engine light off. So some manufacturers will use what is referred to as an evaporative system integrity monitor or module, the ESIM. And now here, there is not going to be a vent solenoid per se that's turned on and off, but when you tear one of these apart and look inside, there are actual weights. And so depending on the pressure of the system or the vacuum of the system, the weights will be lifted or dropped off of their seat. And depending on the conditions, it's going to allow that fresh air to come in or fresh air to go out. So it's kind of acting as a sealed all-in-one unit. Now, because these weights naturally seal the system off, it can actually burp itself by lifting the weights, but it should be in a naturally sealed state at all times. And there's also a set of contacts in there and a rubber diaphragm. And so the ESIM kind of acts as both the vent as well as the monitoring device. So it's going to be able to vent and make sure there's no leaks, but also send that information to the PCM with changing voltages so that the PCM knows what's going on. This is one of those scenarios where we're not going to have to worry about a fuel tank pressure sensor. Now, in older Chryslers, you had the mechanical leak detection system or leak detection pump. Now, this one had vacuum applied to it, and it was electronically controlled. And the easiest way to think about this type of system is more like a bicycle pump. And so what it would do is it would read and calculate the size of the system. It would determine how much fuel is in the system, how much air is in the tank. And it would figure all those numbers out, and then it would say, okay, in order to vent this or purge this, I should take a total of 6 pumps in order to pressurize to a certain level, whatever the PCM is expecting it to be. So whether it's 4 pumps, 6 pumps, however, it knows I need to put this many pumps in to pressurize the system, and then I'll know there are no leaks. However, if it says, and if it thinks to itself, I need to do 6 pumps, and it takes 10 or it takes 12, or it just never pressurizes and it continues to pump, well, now the system knows that there is a leak somewhere, something's going wrong. It's not able to create the pressure, and now we have a problem. And so even though it's a rudimentary kind of design, it was used for a while, and it does get the information to the PCM to let it know, hey, we're not able to pressurize, so somewhere along the line there is a leak. Now, if we fast forward to the electronic leak detection pump, this is a little bit different system here. It's going to use an electric motor, and it was really only used for a couple of years before they kind of went all in with the ESIM that we first talked about. But this one is just a little bit more over-designed. It's got one more variable out there, and again, it adds to a little bit of the technician's diagnostic confusion. So, I mean, here's 3 different systems that work in different ways that a technician's going to have to learn how to diagnose and understand how to diagnose depending on what car comes in the shop that day. And then one of the more primary common ones being used is the last one here, the electric vacuum leak detection pump. Now, some manufacturers like Toyota, they've actually been using this system for nearly 20 years. But the thing about this one is there's a lot of electronics and componentry going on inside. There are different valves. There are different calibration orifices inside. There's a pressure sensor. There's also an electric vacuum motor in there. So there's a lot of opportunities for something to go wrong with this type of pump. And so really the point of showing you these 4 different types is to make this point. Regardless of which system they have, the goal is going to be the same, making sure that there are no leaks present and being released into the atmosphere. It's going to be done a little bit different on different cars, different manufacturers, but the theory is the same. The idea and the goal is the same. But the other point here is to make that technicians are going to have multitudes of different types of systems that they have to learn, that they have to understand, and they have to be able to diagnose. So it does kind of make it a little bit more difficult. The nice thing about our program and your program with Echlin is this: regardless of which system it is, we've got your technician covered. We've got them taken care of. We're making sure this category hits all makes and models and can take care of the customer whenever they have a call. So, we don't want them to be really comfortable with just the eSIM. Everybody knows we have a great eSIM. Everybody's buying our eSIM. But if they don't know that we have the electric vacuum leak detection pumps, they might be calling the dealer for that one. So we want to make sure they know that the entire category is being looked at, not just one type of system. So what are some of the more common failures on these? Again, this is very high level, but the most common reasons will be damaged and worn components along with electrical issues. Now, when it comes to damaged and worn components, obviously age, mileage, your general wear are things that will have a pretty big impact. But also there were a lot of poor OE designs over the years that give us an advantage and an opportunity where we can fix those OE designs. And Jesse's going to talk about some of those here in just a little bit, to make them more durable and make them last longer. But when they do get worn out, like you see on the left here, we're going to have system leaks, and that's going to cause that check engine light to come on. We can also have issues with solenoids and valves sticking open, which again is going to cause system leaks, or at the very bare minimum, the PCM not recognizing what's going on and throwing that check engine light on. And then of course, with electrical issues, this is on anything: cam crank, fuel injectors, ignition coils, especially any place where corrosion is pretty common, or, salt on the road is pretty common. And I'll tell you too, we see it a lot here at the training center whenever we're doing vehicle testing. Vehicles, the amount of vehicles on the road today that are missing fender liners and missing engine covers underneath the car and skid plates that protect a lot of these kind of components, it's just overwhelming. There's so many cars out there missing pieces of plastic that are exposing electrical connectors and components to everything on the road. So not just heat, not just vibration and general wear, but, poor maintenance where something isn't replaced when it should be can cause issues with electrical connectors and components. So it may be a situation where you need to replace just a pigtail, or you may need to replace the component and the pigtail. Either way, we've got you covered, which means you've got your customer covered there as well. So just a couple of quick tips on my end before I pass it over to Jesse. One of the biggest things, one of the most important things when you're doing anything EVAP repair related, after the component is replaced, we need to go into the scan tool and we need to run a self-test to verify, one, that no DTCs have returned, but two, that the PCM can determine and see that the pressurized system is doing what it's supposed to do and there are no leaks, right? Now, in some cases, you may not even have a DTC, but if you look at certain scan data, you can see it's not really performing the way that it's supposed to, but it's not bad enough to hit that DTC, to kick that check engine light on. Some EVAP leaks are going to be very hard to find because it depends on the vehicle, but there's a lot of different lines. There's a lot of different hoses that could be involved. So in some cases, you may actually have to use a smoke machine to find the actual leak. It really is a great way to find the problem. But regardless of whether the DTC comes back or there's not one present at all, anytime we replace something, we need to do a self-test to verify that the system is working properly. Another thing to note is, and this is not just me saying this, experts all recommend replacing the fuel vapor canister when you replace a failed purge valve or solenoid. So remember, most times this is a no symptom check engine light. I think we all can agree that most check engine lights people ignore for as long as they possibly can, even if there is a drivability issue. Well, they're certainly going to ignore it if it's an issue where there's no drivability problems and it's just a check engine light. When that happens, if we go for long periods of time where the purge valve or the solenoid's not working and we're not purging those vapors out, eventually it's going to cause damage to that canister. And so in a lot of cases, it's smart to recommend the vapor canister along with the purge valve at the same time. That way we know when we put the system back together, we're not going to have any more check engine lights. And then one last thing on my end, now you can go back to the YouTube channel and watch last month's Power Hour on EVAP diagnostics, because we make a good point there when it comes to turbocharged vehicles. They can require different and more complex testing. So it's kind of important for a technician to not only understand all these different EVAP components, all these different types of leak detection, but now they're going to have to adapt that to turbocharged vehicles, which is, a lot of the vehicles on the road today and even more coming out every year. So When it comes to EVAP, there's a lot to it. The technicians are seeing it pretty much every day now. And at the end of the day, we have the program that's going to take care of those customers when those vehicles come through the bay. So that's my portion. I'm going to pass it over to Jesse. He's going to talk to you about really what's in your box and what that competitive landscape looks like and what we're doing different to make sure your customers are happy when they purchase those Echlin EVAP components. So Jesse, show's yours, sir. Take it away.
All right. Well, thanks, Corey. And now that we've covered the technical aspects of EVAP, let's jump right into NAPA Echlin's industry-leading EVAP program. So when you reach for the Echlin box, this is what you're getting. 15 global R&D centers, 21 manufacturing facilities, including Greenville, South Carolina, and Independence, Kansas, which specialize in emission control parts. You get the full battery of tests performed on our parts, and Echlin takes things a step further with on-vehicle testing. Finally, you get top-notch sales support provided by our expert trainers, digital content and marketing materials, including videos, flyers, and of course, the full product catalog. Now, the product management team's always on the lookout for emission-related recalls and TSBs to suss out opportunities where Echlin might offer a solution. A great example of this involves failing purge valves on a number of late-model GM vehicles, including the Enclave, Encore, and Traverse, just to name a few. And Echlin manufactures valves designed for improved durability to replace these failing OE units. Let's take a deeper dive into a couple of those. Now, here's an example of an engineering improvement we've made on a popular GM canister purge solenoid. The OE unit on over 5.5 million GM vehicles has a plunger design susceptible to leaks caused by cracking or tearing. We were able to design and manufacture a new component that works exactly like the original, but with an improved design that doesn't cause the seal to fail. And here's another example of an engineering improvement we've made, this time with a Ford canister purge solenoid. The OE unit on many popular Ford vehicles fails at a higher than normal rate because the plunger breaks down and debris from the plunger can cause it to stick open. So we redesigned the plunger, as you see on the right there. We replaced the flaps with a much more durable 360-degree ribbed plunger stop. Now, you've probably heard it before, but it bears repeating. Quality EVAP components are crucial for a vehicle to function and perform properly. So, what does a comprehensive EVAP program even look like? Well, you'll want a program that offers the parts needed for a complete service. Remember, these are systems, and your supplier should be able to offer everything needed for the entire EVAP system, not just part of it. You'll also want parts that are tested for durability and proper functionality, not just in the lab, but on actual vehicles as well. And finally, you'll want design improvements where necessary for improved durability and a longer service life. The part will function as intended by the OE, properly integrating into the vehicle's EVAP system. Our industry-leading coverage will allow you to better service your customers. So let's take a high-level look at what NAPA Echlin offers as the aftermarket's most complete EVAP program. As you can see here, we've got canister purge solenoids and valves, vent solenoids and valves, vapor canisters, leak detection pumps, and purge and vent hoses. Now, it might be helpful to keep in mind that the terms valve and solenoid are essentially interchangeable, and the valve simply refers to a complete assembly that includes a solenoid. And here we can take a look at how Echlin measures up to the competition. And well, folks, the numbers don't lie. Echlin leads the aftermarket when it comes to full line EVAP coverage, and this is especially true of the most critical components, such as vapor canisters, purge and vent solenoids and valves, and EVAP hoses, which means advantage Echlin. All Echlin eSIMs are designed and built at our Greenville facility in South Carolina, and I can't say enough about the work our engineers have put in to make these the best eSIMs in the aftermarket. Our eSIMs are just another example of Echlin's attention to detail that you'll find across all of our product lines. For example, the seal you see on the right of your screen, not only do we include it with all of our eSIMs, our design matches the OE-style H-shaped profile, where most of the aftermarket competition is supplying a traditional O-ring. It's important details like this that elevate the Echlin brand, and something you can be sure to mention to customers. As Corey was discussing earlier, leak detection pumps are one of the more complex components in an EVAP system. As the name suggests, they allow the EVAP system to be pressurized to test for leaks. And given this complexity, you shouldn't be surprised to hear that they require expert manufacturing to perform correctly. And again, our incredible team at the Greenville facility that I mentioned before, They design and manufacture some of our most popular pumps to match OE specifications and set the aftermarket standard for quality and durability. In addition to offering the most complete EVAP program, we also have the smartest. All 9 of the GM OE numbers you see here use the exact same canister purge pump. The only difference are the brackets. The Echlin 2-33032 is a direct replacement for all of these OE numbers, allowing you to cover nearly 3 million popular GM vehicles with just one part number. It's also important to note that this consolidation is fully supported by GM in accordance with their service bulletins. So here's what a complete EVAP repair looks like today, with the 2019 Ram 1500 with the 5.7 Hemi and standard fuel tank as our example. As you can see, Echlin offers everything needed for a complete and successful EVAP repair. And we also offer options for multiple configurations of this vehicle, such as with the Pentastar V6 extended fuel capacity models. And remember that eSIM seal I mentioned earlier? Well, in addition to including it with our eSIMs, we also offer it as a standalone part, 2-71064. And of course, this is just one of many examples where NAPA Echlin offers all the parts needed for a complete EVAP repair. And here you'll see an overview of Echlin's emission control offerings, complete programs, just like EVAP. And as you can see, we've got all the coverage needed across crankcase ventilation, EGR systems, as well as diesel emissions. Now, due to extreme temperatures, water, chemicals, dirt, road salt contamination, the underhood environment is extremely hard on auto parts, as you might imagine. That's why our manufactured emission control products undergo rigorous examination and product validation, including extensive performance benchmarking, product lifecycle testing, and end-of-line testing. And finally, to validate our stringent processes, many Echlin emissions products undergo live on-vehicle testing at our Texas facility. Well, thanks everyone for your time. I'm going to hand things over to Aaron from Marketing Services to take things home. Aaron?
Yeah, awesome. Yeah, thank you very much, Jesse and Corey. That was great. The a couple of things that I want to go over are some of the support materials that we've created for you to help you take some of this messaging to the street. Certainly some of this can be used within your own store, talking to other parts professionals, but a lot of this is really geared for your auto care centers and all of your service provider customers. So you can, hopefully you feel a little better about our program now, and we just want to help back you up with some printed materials. So the first thing we'll talk about is this simple 4-page evaporative emissions program brochure. It's a pretty new piece, but it really does a nice job of surveying the whole program. It speaks to all of the different components that are in the portfolio, as well as some very specific design improvements that we've done on part numbers that address OE weak points that allow them to last much longer than the original part did. The next piece we'll talk about is over there on the right, the new part spotlight. The front side of this speaks to new items that we've recently released. And this helps us tell a very good story about late model coverage and being at the forefront of this. But some of these parts are frankly probably a little too new to really be selling right now. But the backside of this features what we call up and coming numbers. These are all parts that have been introduced within the last 3 years that are really starting to see strong growth in terms of sales out. So we've compiled this data from our category management team, and these are numbers that we are beginning to recommend that part stores add to their inventory so they can be at the leading edge of this. Jesse did a nice job of telling you about how we've been able to smartly consolidate numbers on this pump. So we did create a simple 1-page flyer that can be used, to help explain this, to encourage folks to add that part to their inventory, and why we believe this is going to be a good number moving forward. And then lastly, we can speak to the entire emission control program with this bigger 6-page brochure. Yes, it does address EVAP on one page of it, but it also speaks to what we have available for crankcase emissions, the EGR program, as well as the diesel emissions program that we have that I know you guys have been very successful with. So yeah, we'll move on from here and talk about some of the things that we've done digitally. As was mentioned earlier, we do have a pretty robust YouTube channel to support the Echlin brand with over 550 videos on there. We have an EVAP specific playlist. But one thing that we've recently done, we launched a new training series last year, and we've continually updated that, create new videos. So a few weeks ago, we launched a new EVAP training video. It's only about 3 minutes long, but it does an excellent job of recapping the program and the features and benefits of our parts. It's almost a shortened or distilled version of this 30-minute presentation in 3 minutes. Also at napaechlin.com, under the digital resource section, if you just type in emissions, one of the things you'll be able to click on is a very, very detailed product portfolio. This is a digital book. It's a digital guide. It's almost 30 pages, and it goes pretty deep with some technical information on the components within all of our emission programs. So I think we can start to wrap it up. And some of the highlights of this to recap is coverage. We're fortunate that we are able to go to the market with the most robust, the deepest, the widest EVAP program in the aftermarket. So we don't have to miss sales. We have parts that are extensively tested, both in the lab and on real vehicles. And I know that's a big differentiator. We've done some very specific design improvements to address OE weak points that do not alter the performance of the part, but they do allow it to last much longer than the original parts. And some of these parts are very, very popular because the OE ones obviously fail quite a bit. And then, lastly, we certainly try and support you each and every day with marketing content, training content, and technical training for your service provider customers. So that's what we have today for you. So thank you very much.
And thank you, Aaron, and thank you, Jesse, as well. I think overall, again, it's a quick call, but some technical pieces there, some great information on what you have to go to market with, and then some great sales support on the back end. So again, our hope here is it just kind of elevated your knowledge a little bit on EVAP controls and gives you a little bit more to go think about and talk about when you're having those conversations with technicians or, again, even DIY customers. And so hopefully here in the next 20, 30 minutes, you'll get a call and it'll be about one of these EVAP components, and you'll know exactly where to go in the catalog to look and what to offer and recommend to them, because it's going to be a quality Echlin part. It's going to fix the problem. It's going to turn that light off. It's going to get the car out of the bay and keep it out of the bay. So with that, I'll say thank you again to everybody who has joined us today, and we look forward to talking to you next month when we talk about advanced ICE technologies. Have a great day, everyone.